We remember that the difference between a prism and a pyramid is that a prism's got two bases and a pyramid's got one base. A prism has rectangles as his lateral faces, and a pyramid has triangles as the lateral faces. So a regular pyramid is a pyramid with a regular polygon for a base. Most of the time, our pyramids are going to be regular pyramids. All sides are going to be congruent on the base, so you are allowed to assume that with pyramids. You may assume it. The lateral faces are the triangular sides. We already talked about that. And when the pyramid's regular, those triangles are going to be isosceles. Not equilateral, but definitely isosceles. So the lateral edge, we already know this. That's where the triangles meet up. That's our lateral edge. Now, in a prism, the lateral edge was our height. In a pyramid, the lateral edge is not going to be our height. It's going to be what's called our slant height. Okay? So in a pyramid, this, my pencil, coming from the center of the base, that's my height. That's my slant height. Height, slant height. Height, slant height. So the height is perpendicular to the base, whereas the slant height, that's the height of the triangle on the side. Okay? So the slant height is slanted, if that makes sense. Hopefully you can see in this picture. That blue one is the slant height. We name it with a cursive L. And the purple one is the height. Purple one is the height. The blue one is the slant height. When you join the height, the apothem of the base, and the slant height, you're going to get a right triangle every time. So we're going to be using Pythagorean theorem or 30, 60, 90 or whatever comes up, but we've got more right triangles involved with the height, the slant height, and then the apothem of the base. Let's dive right into our formulas, obviously. This is on your formula chart. The lateral surface area of a pyramid is perimeter times slant height divided by 2, or 1/2 perimeter times slant height, because you know that's how they write it on the formula chart. Perimeter times slant height divided by 2. So it's not the height. When you're finding the surface area, you are using the slanted height. You're using this one, not the one that goes through the middle. Okay? So, given this square pyramid, we know the length of the base and we know the height. So let's find the perimeter of the base, the slant height, and then we can compute the lateral surface area. So remember, you assume every time that the base is regular. So that base, it's not a rectangle, it's a square. So we're going to just do 14 times 4, and that's how we get 56 feet. Now the slant height is going to be revealed using Pythagorean theorem. This is 24. This is 7. Oh, good. That's a Pythagorean triple. 24 squared plus 7 squared. Square root, and you get 25. So the slant height is 25. And then you do perimeter times slant height divided by 2. 56 times 25 divided by 2. Okay? Now, the divided by 2, if you were wondering where it comes from, when you remember, the lateral faces are triangles. So when you're finding the area of a triangle, you do base times height divided by 2, right? That's why the height of the triangle is your slant height, and your base is part of the perimeter. So you're really doing base times height divided by 2, base times height divided by 2, and you're really doing it 4 times, which is where your perimeter comes from. So if you were wondering why we're dividing by 2, the reason is because your lateral faces are triangles. Okay. So next one, total surface area. Now, for a prism, It was take the LA and then add 2B. But for a pyramid only has one base. So take the LA and just add a base. So take the lateral area and add the base area. So we already know the LA, it was 700. Now we need to find capital B. Some people, when they're working problems too quickly, they'll just put 14. Because they'll go look at their base and they're like, oh, there's 14 on my base. And so they'll just put 14. But remember, capital B, that is like, I call it a loaded variable. Capital B stands for area of the base. You have to actually find the area of that base. So 14 squared, because the base is a square, side squared, 196 square feet. And then you just add them together to get your surface area. You don't have to double anything because there's only one base. We okay with this so far? Next is volume. And I know you already have your formula chart in front of you. So I could just reveal the volume formula to you right now. But I think this is a cool one to see how it works. Here's a prism, and here's a pyramid. And they have the same base. How many pyramids could fit into my prism? How many pyramids could fit into a prism with the same base? And when I just look at it, to me it looks like only 2 of these guys could fit into here. It doesn't look like there's that much room to fit that many more. But when you use an actual liquid, let's see if we can do this experiment. Usually I have kids come up to the front so that I have more than one hand. Okay, there's my prism, and now I'm pouring water into my pyramid. So I'm pouring it 1 time. Oh, there's 1. Do you see how much that's filled up? And then here's 2. I'm going to be a little bit short because I'm not filling these all the way up because I don't want to get water everywhere. There's 2 pyramids. Man, 2 wasn't enough. How many pyramids does it take to fill a prism? And there's 3. Hey, boys! So pretend that went all the way to the top because remember I wasn't filling it all the way up. Okay. Anyways, the moral of the story is, how many pyramids fill a prism with the same base? And the answer is 3. You have your formula chart in front of you, so you could see it right away, but I thought it's cooler to have an actual experience with it. So, the volume of a pyramid is the same as the volume of a prism, except you divide it by 3. Well, you should always have a formula chart. Go get one. We'll figure it out. Print one out from online. I have one on my website. All right, so we already know. Oh, this is a new problem. Let's find this one. Okay, what'd y'all get for area of the base? Anybody? I got 9 root 3. Yay, Albert, very good. The height is handed to us on a silver platter. And so now to find the volume, we just do base times height divided by 3. 9 times 9 divided by 3. Base times height divided by 3. When you have pyramids, when you have any shape, rather, sometimes it helps. When you're finding capital B, I would redraw the base staring at you. Don't redraw the whole solid, just redraw the base. This is an equilateral triangle with sides of 6. And then you can find the area of that however you would like to find the area of that. If you're having trouble with capital B, redraw the base facing you. So there's our formulas, which are on your formula chart. Let's do this one, and this will pretty much end our day because this is a pretty big one. I know, thank you. Okay, so good job, Helaman. Perimeter is 4 times 6, so the perimeter is 24. Minjung, what about the slant height? Let's do one at a time, guys. Let's do Minjung next, because if we don't get the slant height right, we're going to be in trouble. If this is 4, we need to know what the apothem is. So this is 2. The apothem would be 2 root 3. So if we want to know the slant height, we've got a triangle, and we've got 6, and we've got 2 root 3, and then we've got, I don't know. This is the hardest example I can give you, so don't worry if you're having trouble with this one. So we're trying to find the slant height, so we would do a squared plus b squared equals c squared. 36 plus 12. Okay, where did I lose you? Good, 4 root 3. So remember, that triangle, it's made up of the height, the apothem, and the slant height. You had to find the apothem. You had to find the apothem of that hexagon. So that's why the slant height is 4 root 3. The lateral surface area is take the perimeter times the height, the slant height, and divide it by 2. So 24 times 4 divided by 2. You're all getting 48 root 3. Let me know if you get something different. Thank you, Jenny. So the base is a hexagon. Apothem times perimeter divided by 2. So we take our apothem, we multiply it by our perimeter, and we divide by 2. So 24 root 3 is perfect. Quan, what about a surface area? You take the LA and you add B. And those are like terms. They both have root 3. Very good. So 48 plus 24, 72 root 3. That's nice. They're very rarely like terms. That's good. All right, the height. Oh, sorry, Austin. I gave you a way too easy one. Sorry. Yay. The height is 6. And George, the volume. Base times height divided by 3. Very good. 48 root 3. Whew, that was an intense. So it's asking to find the surface area of this figure. So what you need to realize is which parts are we not going to use. So let's do the surface area of the bottom first, because that's going to be the easiest. The surface area of that one is going to be the LA of that one plus B. We only want one of the bases because we can't touch the other base. The top is not on the surface. So if we did the LA, that would be perimeter. So 24 times 4. That would be the perimeter times the height plus the area of the base, 24 squared. So I am getting the surface area of that rectangular prism right now. 96 times 15 plus 576. So a very large number. That is the surface area of the rectangular prism. Now we need to find the LA of that pyramid. We only need the LA because we don't need the base. We don't want the base. So we're just going to find the LA of the pyramid. So the LA is going to be, remember, 1/2 perimeter. Well, we already found the perimeter. times the slant height.